Okay, so what is the first thing we are always supposed to do? Plug it in. So we are always supposed to plug in first. Uh-oh. So I'm writing it down just to remind ourselves. You can do it in your head, that's fine. But I'm going to write it down. We would try 1 over 0 plus 2 minus 1/2 all over 0. That is going to be 1/2 minus 1/2 over 0, which is 0 over 0. So did this work? No. This is indeterminate. Indeterminate can never be your answer. If you get indeterminate, you have to do more, right? So, whenever we're dealing with complex fractions, what you probably need to do is try to combine things and get it back down into just like a regular fraction, right? So for this particular case, you have a few options on how you want to deal with it. I would get common denominators and put the stuff in the numerator together first. So I would put the 1 over x plus 2 and the 1 over 2 together. So when I'm looking at just the top, I'm kind of ignoring the bottom for right now. I'm going to try to look for a common denominator. Solomon, what could I use for a common denominator here? I needed 2, but I also have to have a x plus 2. So pretty much what you're doing here, like, you can't, like, it might be tempting to do like this, x plus, that would be nice, right? Then you just got x plus 2 on the top. But think about doing that with numbers. If I have 1/2, can I take plus 3 plus 3? Can I add something to the top and bottom and it's still equal? No. So you cannot do that. What you're going to have to do, I really shouldn't have written that because the stupid thing doesn't have a good eraser. So basically what you got to do is I'm going to take this fraction and I'm going to multiply it by x on top and bottom. I'm sorry, not x, 2 on top and bottom. I'm looking at, let me just erase everything. That indeterminate won't matter. Okay, let me start over because I've made a mess. I'm going to multiply this by 2 on top and bottom. And then I'm going to multiply the other fraction by x plus 2 on top and bottom. And so then I have common denominators. Both of my denominators are 2 times x plus 2, right? This will always work. Sometimes it might be more helpful to simplify a little first before you do it, but this will always work. Just multiply the fraction by the denominator of the other one. Okay, so this is going to be the limit as x approaches 0. We're supposed to hold on to that limit notation. I'm going to do it this way. 2 minus, I'm going to keep this 1 times x plus 2 for one important reason right here. And then since these have the same denominator, I'm just going to write it once. 2 times x plus 2. And then keep in mind, you still have this x on the bottom. Don't lose it. It's very easy to lose that x because we're not really doing anything with it right now. The reason I kept this 1 right here is because when you have a minus, it's really easy to lose that minus. That negative gets distributed to both of these here. So that is going to give us 2 minus x minus 2 over 2 times x plus 2 over x. Anybody see anything helpful here that we could do to simplify a little? I can distribute that 2. It is probably not going to get us anywhere, but it wouldn't hurt if you did. You just might have to factor it back out. But what's more helpful here, this 2 is going to cancel with that -2. Oh, and I was also lazy. What did I forget on that last one? Limit notation's really supposed to be there. Especially if it's a free response question, it needs to be there. So let me go down to the next line. I got limit as x approaches 0 of -x over 2 times x plus 2 over x. All right. So now I do have these like combined, right? What are you guys thinking now? What should I do? You generally never want to have fractions inside of fractions, right? That make things too complicated. You don't want to have a complex fraction. So think about it like this is your top fraction. What's your bottom fraction? X over 1. Dividing fractions is easy as pie. Flip the second and multiply. So we got the limit as x approaches 0 of -x over 2 times x plus 2 times 1 over x. Okay, did you see anything good happening here? The x's can cancel because when you mark them out, they are separated from what's left by multiplication, right? So those x's can cancel. When x cancels when you're doing the limit, you probably can now do direct substitution. I'm gonna write this up a little prettier before I do though. So that means now we've got the limit as x approaches 0 of, in the top we just have a -1. In the bottom we've got 2 times x plus 2. And so when you plug the number in, that's when you can quit writing the limit notation. So we got 2 times 0 plus 2. That is going to be -1 over 2 times 2, which will give you 4. So you have -1/4. Okay, questions? All right. So similar to our warm-up, except for this one, you needed to like do the subtraction first, and then you had to flip and multiply on this one here. You guys try this one on your own. I'm gonna freeze my screen and work it out up here. Okay, so common denominators, you got to multiply by x plus 2 and x plus 2 here, 5 here and here. You're going to get a combined denominator. You're going to distribute. You should end up with 2x minus 6 over 5 times x plus 2 at some point. You need to flip and multiply. You're going to have to factor out a 2 right here, and then you'll have an x minus 3 on top and bottom that can cancel. Then you'll be left with this. You need to plug in your 3, and you get 2 over 25. Notice that I kept my limit notation all the way to here, and then I dropped it when I plugged the number in. That is like textbook correct. I know you're thinking, I don't want to do that. It's stupid to have to write it. But it is not mathematically correct unless you keep it that way. Multiple choice, yeah, you can get by with just like shortcutting it and not writing it properly every time. Free response, it may or may not affect you depending on how the rubric is set up for that particular problem, but I would not risk it just because I was too lazy to write limit as x approaches 3. So whenever you have free response stuff, I would highly suggest that you keep that limit notation until it's okay to drop it there, because you will lose some points sometimes if you don't. Okay, questions? All right. Okay, let's look at this problem. This one is different than the ones we have looked at so far. What do you see that is different about this problem? There's a square. We hadn't really seen that. Anything else? I've got an x and an h. There's 2 variables in this problem. So that makes this problem quite a bit different than the like other ones that we've seen, because everything else has only had a single variable, right? So let's check it. No matter what, you want to check direct substitution first. That's always your go-to, because sometimes they have snuck a direct substitution problem in the middle of all these other hard problems, and you're going to miss it because you forget to check direct substitution. You just assume you're going to get 0 over 0. So if I check this, I would have 1 over, what letter gets replaced with a 0? H, not the x. So I would have x plus 0 squared minus 1 over x squared over 0. So only the h's are replaced with zeros, not all the variables, just the h's. This is going to give me 1 over x squared minus 1 over x squared over 0. What is 1 minus x, 1 over x squared minus 1 over x squared? It's 0. Anything minus itself is 0, right? So this is indeterminate. Meaning that we're going to have to do something here. So, ideas. What do you think we could do? Actually, no, they're not going to go away in this problem. What's going to happen in this problem, just because I already know how to do it, we're going to have x's in our answer. Our answer is not going to be a number answer like we get 7. It's going to be like 7x plus 2 or something. That's not even close to what we'll get, but it's going to have an x in your answer. So x's won't go away. Let's just think, it's a complex fraction, right? Let's think about the last one we did. What's the first thing we did to solve it? We got common denominators, right? So I see I got an x squared right here. So I'm going to multiply this one by x squared on top, x squared on bottom. And then on the second one, I need a x plus h squared and an x plus h squared. So it's a little complicated. But now I'm going to have limit notation. And I'll have x squared minus x plus h squared over x squared times x plus h squared. And then don't forget you still have this h on the bottom. Sometimes I even like to put like some parentheses around that numerator to remind me that I'm like working on that part. Can I cancel the x plus h squares now? Got one on top, one on bottom. I cannot. Why not? This minus sign right here. So if you're wanting to cross it out, and notice that, hey, what's left is separated out by a minus sign, then that tells you can't do it, right? Or a plus sign. So I can't cancel these. Can I cancel the x squareds? Feels like it, like we're trying to do something here. But no, same reason. Because if I mark those out, what's separating that x squared from the stuff that is left up here is a minus sign. Right, so in the bottom it'd be fine, but in the top I can't do it because of that minus sign. So I'm not going to be able to cancel right here. So any ideas? What should we try?
Distribute the x. X you could x plus h times x plus h.
Okay, let's do that. X plus h times x plus h. Let's expand this right here. So the best thing to do is square, double square. Do it in your head, more efficient. I'm going to write it out over here on the side just to make sure that we all know why we're going to get the answer we get. You do x times x, that'll be x squared. You do x times h, so you get plus xh. You do hx, so I'm going to call that plus xh again. And then we got plus h squared, right, which is x squared plus 2xh plus h squared. I do this in my head. Square the first, I get x squared. I multiply them together and double it for the middle. That's 2xh. And I square the last and get h squared. So be careful with your signs here, because this is minus all of this stuff. X squared plus 2xh plus h squared. And on purpose, it is fine if you went ahead and distributed it in that next step. I would if I was not doing this to make sure everybody's following me. That negative has to get distributed to everything here. With the limit as x approaches 0 of x squared minus x squared plus 2xh plus h squared over x squared times x plus h squared all over h. Whew.
Why would the negative go to 2xh and the...
Oh, it would. Because I'm doing things wrong. That's why. It would go to both of them. Yes, this should be minuses for all of those. Thank you. I'm being careless. Okay, anybody see anything that's happening that feels promising a little bit at least? X squared and x squared is going to cancel. All right, that is going to give us the limit as h approaches 0 of negative 2xh minus h squared over x squared times x plus h squared all over h. All right. Any ideas?
Would you explain more to the video, like the first one?
You can. I probably wouldn't at this point because, like, what you're looking for to happen is like something to cancel, and particularly you need an h to cancel since h is approaching 0. Like the x is just canceled, but since that's not the value that's approaching 0, it's probably not gonna get us as far as we need to go. So I'm looking for something to cancel, and when I want things to cancel, I want them to be factored. I don't want them to be multiplied out, so I probably just need to leave it. Now I do have, like, I've got my fractions all together now, right? Like I've got a top fraction, that's one single fraction, and I've got a bottom fraction. What's it over? 1. So we could at this point do dividing fractions easy as pie, flip second multiply. It still is going to look pretty bad, but at least we won't have a fraction inside of a fraction anymore. All right. We were really, really close at this point.
That h cancel with the h and 2xh.
Good question. Can this h cancel with this h right here? If you mark them out, this h is separated by a minus sign with these other h's. But both of these have an h right here, right? What can we do?
You can factor out the h.
I could factor out the h. That's going to look like this. I'm going to have an h times negative 2x minus h over x squared times x plus h squared times 1 over h. Now, if I do what Layla was suggesting, if I mark out this h and this h right here, are those h's multiplied by whatever you have left, right? This h is being multiplied by this expression. This h is being multiplied by all the other stuff, right? So it's okay to cancel now. So your thought was good, but it's got to be factored out first before you can cancel it. So when a h cancels, you're probably good to do direct substitution. Let me clean it up just a little bit. I'm running out of room here. I'm going to write it one more time, just a little bit cleaner. I've got negative 2x minus h over x squared. Oh, I also messed up. I've messed something up. You guys see it? I've put x approaches 0. I had an h here, then I went to an x, then I did go back to an h over here, but then I went back to an x. Everything was supposed to be h the whole time. My brain is just defaulting to what I see the most. You guys ever done that when you're driving? Like you just like, you're going somewhere else, but you just like I just go straight through the light like I'm going to Elkin High School. This is what's happened to me here. All right, now it is h, not x, because I hadn't messed that up. All right, h is approaching 0. So we're going to try direct substitution now. We're plugging in 0. So we're going to get, we're only replacing h's with zeros. Negative 2x minus 0 over x squared times x plus 0 squared. And so when I do that, in the top, I just get negative 2x. In the bottom, I'm going to get x squared times x squared. What is that? X squared times x squared. X to the 4th. Can I simplify that any further? I got 1x on top and I got 4 on the bottom, so I can cancel one of them out. And that will give me negative 2 over x to the 3rd. And this, finally, is your final answer. This is a fun problem right here. This is the ones that you go home and show your parents and be like, Mom, look at what I'm doing in class. Or if you make a bad grade on something, you go take this problem and say, you know, if they're fussing at you for making a bad grade on your calculus stuff, you take them this problem and you say, could you help me with this since I'm doing so badly in calculus? I need your help. And then they're probably going to maybe understand that it's a pretty hard class there. So those are fun. I like them. If you see a problem like this that has that other variable, not every time, but a lot of times, you end up with having a x still in your answer. Not every time, but most of the time. If there are two variables, there's still going to be one of the variables left in your answer. When we get to homework, I'll show you. Our book does not use an H. Our book uses a delta X, and I will show you what to do with that when we get done with this here. Okay, let's look at this one. Okay, again, we've got an H in this problem. So this one has H's and has X's. This means that we are probably going to get an X left in our answer. Because I know more than you, I think I know more than you. I think our answer is just 4x. But I know more than you know right now. So, I can't tell you my secrets just yet. I will eventually. Now, this one's not a complex fraction. This one I think is actually probably easier than the last one that we did. Instead of like factoring and canceling here, we actually kind of need to expand, right? So I've got that x plus h squared. We just did it a minute ago, right? It's x plus h times x plus h. And we are going to square the first. We'll get x squared. We're going to multiply the middle together and double it. We'll get 2xh, or you could do it this way, plus xh, plus xh, and then we square the last, which is h squared. We're going to get x squared plus 2xh plus h squared. So that's this part. We're going to have the limit as h approaches 0 of 2 times x squared plus 2xh plus h squared minus 2x squared all over h. Okay, Raleigh, what do you think we should do next?
Cancel out the 2x squared.
Okay, on my work, I have not distributed my 2 yet, so I need to do that, and then we can cancel it out.
Yeah.
And if you kind of did that all together where you've distributed the 2, that's fine, as long as you're not messing it up. In calculus, they are pretty lenient on doing work in your head, as long as you don't write down things that are like completely wrong. Okay, so the 2x squared here and the negative 2x squared can cancel. That's going to leave us with the limit as h approaches 0 of 4xh plus 2h squared all over h. Okay. Any ideas now? Factor an h out. So limit as x, switching back to x again, h approaches 0 of h times 4x plus 2h all over h. Now the h's can cancel. I'm going to tell you, if you have a problem with a h in it, it's probably, that's going to probably be a step somewhere. You got to factor out a h, and then the h is canceled. That happens almost every time with these problems. So now I've got the limit as h approaches 0 of 4x plus 2h. We can use direct substitution now. What letter gets replaced with 0? H, not x. So 4x plus 2 times 0, and that is going to just give us 4x, which is what I said the answer was in the beginning. I don't have an answer key. I knew that off of the top of my head because I know a secret you don't know yet. I'll teach it to you eventually, but there's no way I'm getting you to do all of this if I teach you my secrets yet. So, and they give us some of the stuff on the exam, so I need to make you do it. All right. Let's see. Okay. Exponentials. There are I'm gonna say there is not enough time to do this, is what there is not properly. Let's hold off on the exponentials for today. We'll try to do those at the beginning of class tomorrow. So let me see what I need to take off of your homework assignment, if any. Let's see, 61 through 66. You should be good on all of those. 79 and 80 are the ones that, okay, 79 and 80, take those off. Don't do those. I do need to make sure your book does something different than I did with the H's, okay? Your book uses a delta X, which means like change in X. So like when you look at like 63 there, the problem looks like this. The limit as delta X approaches 0 of 2 times X plus delta X minus 2X all over delta X. Okay. Delta X is a single variable. It is not two things multiplied together. It is just a different variable. My suggestion to you, because it makes it less confusing to look at, is to take your delta X's, say, I mean, if it was a free response, you would need to say let delta X equal H, and just change it to an H like we were doing. Limit as H approaches 0, or just write it down with an H instead of a delta X in the very beginning. So 2 times X plus H minus 2X all over H, like that. So when you see that delta X, it could just be replaced with a H if it's confusing to you. You can keep it if you would like. It looks kind of fancy, but it's easier to calculate with an H. So you got about 10 minutes. So I want you to go ahead and get started on these. You got a few rationals, a few with the delta X's or the H's, and that'll be good enough for practice tonight, I think.